Hello, welcome to the Intelligent IoT Gateway Lab series. My name is Ishu Varma, and today we'll be talking about how to build Intelligent IoT Gateway using open source technologies. The main components of the lab are Red Hat Enterprise Linux to provide enterprise class foundation, Fuse to transform sensor data and route it to the endpoints, A-MQ provides the message broker for the sensor data, and the BRMS enables real-time decision making at the edge. We'll be using the Ansible automation tool for provisioning our gateway. Let's look at the lab workflow. On the host machine, we'll be using the Ansible playbook to build the gateway. Once it's complete, we will switch over to the gateway that we just provisioned. First, we'll start the Fuse. Then we will build and deploy the routing service, followed by starting of the Java app that simulates the real-life sensor. We will then create the business rules using a spreadsheet, and finally we'll build and deploy the rule service. Let's begin the lab by going to the Red Hat IoT demo page on the GitHub, and we can see our lab virtual IoT gateway here. So we will download this repo on our host machine. So step one is git clone this repo. You will notice it's fairly small download. It's only downloading the required Ansible files. And the files we need to modify are build, gateway, build GW, and the hosts, which are under the Ansible directory. So let's look at these files first, starting with hosts. And host is where we need to put the IP address of the gateway. So let's first find the IP address of the gateway. So in our case, we'll switch over to the gateway now, which is another VM on my system. And we will find this IP address. And once we have the IP address, we'll go back to the host file and update it with the gateway IP. Once we are done with that, we will save this file and close out. And then starting to look at the other file of interest, which is the build GW file. First, we need to modify the username of the gateway. For us, we're using demo user. But in your case, please modify what the username for your gateway is. And looking over this file, you don't need to change anything, but just browsing over the contents, you can see that we are enabling a couple of repos, installing required packages, Maven and Git. And then we are downloading the gateway, the code on the gateway itself, so which is a different branch. This has the actual code for the gateway. And once we have the code downloaded, we will move the JBoss Fuse file from the download directory, which is a prerequisite for this. So we'll move it to the right location and we will install it, which is as simple as untarring the file. With the soft link created, we will move into actually downloading other packages. So the only other package we need is the LibreOffice because we need the spreadsheet to create our business rules. So we will go ahead and download the LibreOffice and in next couple of steps install it. Now the last step in the playbook is going to be building the soft sensor, which as I mentioned earlier simulates the temperature data. So let's close out of this file and we will go ahead and start this playbook. So the command is very simple. You essentially do the Ansible playbook and name of the playbook, and it starts the process of provisioning the gateway. And it will go through this process. So we'll let it run through this process. And now the Ansible playbook is finished. So let's look at what it did for us. So it went through each of the tasks we had listed in the build GW file and completed the tasks. So now we are ready to move on to the next step. Step 2 is logging into the gateway. So in our instance, we will switch over to the gateway VM. Looking into what the Ansible has created for us, we can see that it has created the IoT Summit Lab for us. So we'll change into this lab and see there are a number of scripts available for us. We'll start off with starting the Fuse, so running the script that launches the Fuse server. Once the Fuse is complete, we will install the Camel MQTT adapter because the sensor will be sending the data through MQTT. Once that is done, we will minimize the console for Fuse. Step 4 is to build and deploy the Camel route. So let's open a new terminal and we will run the routing service that builds and deploys the Camel route. So as we can see here, the build is complete. And now we can proceed to the step 5, that is to create business rules. Let's open the sample business rule table that we have provided here. It's under the business rules service. And once we click on it, it will open it in the LibreOffice. And here we'll be creating 2 rules. Rule 1 for low temperature. Between 0 and 60, the result field will be 1. And for high temperature, between 61 and 100, the result field will be 1. Once we have populated these 2 rules, we will be saving it and closing it. Step 6 is to build and run the business rules service. So we will be using the test script run rule service to build and deploy this business rule service. It will go off, download the package, build it, and then deploy it. Once the build is finished, we should see the message A-MQ broker is ready to work. And now before going to step 7, let's look at the Fuse console and see the services we have deployed so far. So we will go into localhost, port 8181. That brings us to Fuse console. We will log in using admin and change _12me. And proceed to looking at the various services. So here you can see there are 2 queues, message to data center service and message to rule service. Looking at the various queues of special interest, here is the IoT demo temperature. That is the queue that or the topic that's where the sensor is sending the data over MQTT. So now let's proceed to the last step of this lab, which is to test the rule service. So we will launch another instance of terminal and look at the various sensor scripts available. We will start off with the run high sensor script, which sends one high value of the data. Now there are 3 things happening here. First of all, the software sensor sends the high value data over MQTT. The routing service picks it up and sends it to a AMQP message queue. And then finally, the business rule service kicks off and transforms this message from the queue and put it in another queue, but only if it meets a certain business condition that what we specified in the decision table. So this completes the lab. You can see that as I kicked off this message, the message enqueued and dequeued count has increased. And you can look at a couple of other scripts here and try to see what happens as you play around with your decision table, how the different queues and messages are being affected. Thank you for watching.